Okay, well, I want to look at that graph again, and we can actually use that graph to figure out other information or estimate other information from the information we have here, and that's called extrapolating. And so I can ask a few other questions about this person's growth over those 16 years. Okay, so I could ask, okay, well, at what point was he 120 centimeters? Or how much did he grow from the age of 2 to 5 years old? And so we can do that just by looking at the graph and reading the information off there. So I want you to pause the video now. I'll give you 3 seconds, and I'll kind of show you how to solve that if you can't quite get it. So pause the video now and go ahead and try that. Okay, well, let's first of all figure out answer number A there, where he was, or how old he was at 120 centimeters. There's 100 centimeters, there, 110, 120. So this is where he was 120 centimeters. It lines up kind of right in the middle of this line here. To figure out his age, we kind of drop down to the horizontal axis and estimate his age. So 3, 4, 5, 6, 7, about 7.5. He's 127 meters at 7.5 years old if we assume a constant rate of growth like we have. Okay, and then how much did he grow from 2 to 5 years old? Well, let's have a look at that. Where's 5 years old? Right there, and we count up here to the graph, and there's where he was at 5 years old. And again, we're estimating his height there, and that is, looks like it's going to be 100 and let's say 108. I don't know. So from 90 to 108, whoops, 108. So he grew 18 centimeters. 18 centimeters from the age of between the age of 2 and 5 years old. So you can just use the graph you get from whatever data you get to find more information just by extrapolating, and that'll come up a lot. Okay, one of the other things you'll have to be able to do is write equations to demonstrate a rate of change. And so I'll just give you a second right now, pause the video and read this question over. And you should hopefully be able to figure out that there is an initial amount of money you have, and then it decreases at a constant rate. And that constant rate is the slope that we need to figure out. So before we write an equation, and let's just keep in mind something here. And just remember that to write an equation, for us, these linear equations are going to be in the form y equals mx plus b. You can do it that way, okay? In other words, that's your slope, okay? And then this is the x variable. Okay, well, let's try and look at it that way if you want. Okay, well, first of all, the rate of change is going to be the change in the y-axis, the change in the vertical axis over the change of the horizontal axis. So we're trying to find the price change, or sorry, not the price change, the balance per year. So year goes on the bottom. So if I'm finding my slope, delta y over delta x, it's years on the bottom, and the change in money is going to be 390,000. Okay, and so that gives me an average rate of change per year. So $390,000 divided by 13 years, that's 30,000 per year. Okay, so to write an equation then, that's my rate of change. So I could say it this way. The balance of my account, B, I'm going to call it B for balance, is equals, well, the initial amount is $600,000. Okay, and I'm losing $30,000 per year, okay, times the number of years. So after 1 year, I'd lose 30,000, after 2, etc., 60, like that. You can look at it that way, okay, and maybe we don't want to use y, let's want to use t so we don't confuse it with the other one. And then in the format of y equals mx plus b, okay, my vertical axis is my balance, the slope is that rate of change there, this is my um, uh, horizontal variable, and 60,000 is my initial amount, in other words, my y-intercept. Okay, and with that in mind then, what I'd like you to do is to try to do this part here, graph that data, and find out how long it takes to deplete the account, and I'll show you my solution in 3 seconds. Okay, so there's the graph in its lovely glory. Okay, starting out at 600,000 and passing through 21,000 there at 13 years and ends up at 0 at 20 years. Okay, I know it's a lot, but it's a good introduction. We'll finish the lesson off tomorrow. See you then.